Okay. So let's talk about normal forms. So what do we mean by normal forms? Normal forms has to do with the level of normalization of a table, right? The level of normalization applied to a maybe probably to a database design. Let me put it that way. And there are different types of normal forms that we'll talk about today. We have the first normal form, the second normal form, the third. I don't know if there are so many others though. But the ones that I'm very familiar with is the 1NF, 2NF, and the 3NF. So what is first normal form? So before you can achieve first normal form, there are some conditions that one needs to meet before one can achieve first normal form. So the conditions is that all the columns must contain atomic values. So what does that mean? It means that they must contain values that cannot be divisible. It means that these values you can no more, when you have gone so granular on something that you cannot, divide it again, right? So you have to go to that level of granularity before you can achieve one normal form. We are still going to do a hands-on for you to see how you can change a table from whatever form it is to a one normal form. Another condition to achieve a one normal form is that there are no repeating groups or arrays. There are no repeating groups or arrays. The essence of normalization, whether it is one normal form or two normal form or three normal form, is that we want to avoid redundancy. We don't want repetitions across, right? We want to make sure that our data is well normalized to a point that probably faster queries and you want it to respond as fast as possible whenever you click on that your refresh button, right? So one normal form, another condition for us to achieve one normal form is each column must contain values of one type. Each column must contain values of one type. It means that the data type should be applied on a column, right? Each record row should be unique. Now, if you look at this table you are seeing on my screen, you will see that before one normal form was achieved, what did you see here? Look at the columns that we have there. We have the order ID, we have the customer name, we have the product name, and we have the order date. What did you observe about this table? What's your observation about this table?
Product name has arrays of values.
All records are unique.
Product name has arrays of values.
Product name
That
has
is more than arrays
Yeah,
of values. That
more
is
than
more than
one
one
value.
value.
Yes. So you see that this is not one normal form. This is the way the raw data came from, right? So your should I call them data architect or your data engineers or blah blah blah. They understand this more better, right? And they know what to do when they see this kind of tables, right? But as a Power BI developer, it's very important for you to know all these technologies because it's going to really help you your understanding of data and how data architecture works and how the design of databases and those things. Because just sometimes the painful part is that what some companies call data warehouse sometimes is actually just a copy of their OLTP. Do you understand? A copy, an exact copy of their OLTP. Like they didn't apply any maybe they didn't even apply any ETL or anything to restructure the data to make it a star schema, to make it more analytical ready and all of those things. You just copy the same data from the source, create a copy of that and they will call that a data warehouse. That is unfortunately what we see happens in most organizations, right? So you see that in product names, you see that we have apple, banana, we have grape, apple, mango on one row, and it's not meant to be so. But when I change this to a one normal form, I apply one normal form on this. So what is going to happen now? This is now how the table is going to look like. Now, what is the difference that you see between this one and this one? Anybody? Any observation? Before we applied one normal form on this, and now that we have one normal form. What did you see? What is your observation?
There's redundancy.
There is what?
Redundancy.
Hello?
Repetition.
And then you have each value in a single row. You don't have them mixed
What do you
together
mean by
again.
there's redundancy? What do you mean by that?
Redundancy is repetition of data. So we have 101, 101, John Smith, and the date as well in that row. Aside from the fact that the product name actually splitted into apple and banana, but we still have redundancy of the other IDs, the customer name, and the order date.
Okay. But in the real context, you will say there's redundancy per se.
Yes, that's repetition of data.
So no. How best do you not think it should be represented?
No, we are still on one NF now. So this one is normal for it to be like this.
Redundancy per se, the ID needs to change.
The ID needs to be unique.
But they are the same order now. It's John Smith that bought apple and banana. So it's not.
The IDs cannot be unique.
The ID cannot
in one
be
order there are several products.
Exactly. So probably we create another column for product ID or something like that, which is the next one we are going to.
Now, let me ask you something, guys. Do you understand this one normal form? Do you understand how this table went from this state to this state? Do you understand it?
Yes.
Do I have to go back to the conditions? All columns must contain atomic values, right?
Yes.
But in the actual sense, does all the column contain atomic values from this table? Yeah. I want responses. All the columns that you see, do they contain atomic values in this new one?
Yes.
No.
How?
Customer name.
Customer name. Thank you. What's the issue with customer name?
We can split customer name further into first name and last name.
God bless you. Thank you. That's what
and
I
then
want to
even
hear.
the other date, can't we extract year, month, and day from that other date?
Let's leave down. Let's leave down.
All right.
Let's leave down. Let's just focus on the customer name. That one is okay. So the customer name, we can still break it down to what? To first name and last name. Right. So follow me, Joe. Your hand is up.
Good evening, Mr. Benga. Actually, I think I've already put it down actually. So, well, I just want to explain something that we should not confuse ERD and data modeling together. The way ERD is a little bit different from model. So I think the question that what I actually want to refer to was when someone mentioned redundancy, that the table was redundant, and I think you also want to ask the person why he said that. Well, in this context, we might not really say that it's redundant, because if you look at what one NF is telling us, he's just telling us that, okay, make sure that each records are not, well, we don't have, we have an atomic values on each row, which we have already achieved here. But trying to say, oh, it's redundancy or not, we are going to, what the 1NF is telling us here is not going to be achieved here. So I don't know. I think Isaiah hand is up. Maybe you want to add or remove.
Isaiah.
Okay, so
thank you.
I think I just have I would say, is it a question now? I'm trying to look at that customer name again. In that column, we don't have a list of array there. It's the name represents the name of an individual, as opposed to the previous table where we have the list of product name in a particular column. I'm just trying to look at another dimension to it, because when you said that, you asked a question and I look at the records again and I said that this customer name can actually be split into first name and last name. But if you look at it in a way, it's a name of the person. It's not a list of names of people, as opposed to the previous record we have. But I don't know if you can shed more light on that, so that one will know where to draw the balance.
So let's look at these 4 conditions that we have here. All columns must contain atomic values. Did we achieve that? Let's try to check box. Did we achieve that?
Yes. We already
Yes,
achieved that. Yes, Mr. Gwen.
We already achieved that part.
We did not achieve that, guys.
Okay.
Because that John and Smith can still be divisible.
Oh, well, Mr. Gwen, I want to agree with you. I want to agree with you. One thing is that if you say apple and banana, apple is not banana. But if you say John and Smith, for example, I can say Benga, you will respond. If I say Adeyemo, you can also respond to me. I'm still calling you. But if you say apple, banana, they are 2 different things. But you can still call John Smith as one person, one individual. So when you see atomic here, it already, what 1NF is saying here has already been achieved with this customer. We can still further break customer, but in this case, we have already achieved it.
We have already achieved 1NF already, so we don't need to break customer name again. Because if you break customer name,
but the condition says all columns contain atomic values.
I think what we should try to divide, what is atomic value?
Dividing that customer name will not make
last
any
speaker
sense.
now, your judgment depends on human judgment. If we are talking about computers, for instance, now, if you say Benga is equal to Adeyemo, that's false. So they are 2 different things, even though they represent the name of one person.
Sorry, I didn't get that.
I am saying that in computer, for instance, if you say Benga is equal to Adeyemo, it's not true. They are not the same. So it is
well, you maybe what I'm trying to say is that
person.
Yes. If we have customer ID in this table and you still want to divide it again, it doesn't make any sense. You understand? What I'm just trying to say is that with 1F, what we should focus on is the 1F rules, right? We should not look outside that.
Don't let us argue too further. 1NF, for us to achieve 1NF, when they say atomic values, indivisible, it is important for us to break customer name down also. That is the actual meaning of atomic values. A single value, indivisible piece of data. It means that so far we can still divide this customer name in 1NF, we must separate them. Do we understand? If a full name is not atomic, full name is not. All of us can do your research as I'm talking now. You can be doing your research by the side. For 1NF, we still need to divide, because as in we must. That's why I started my word with, I said we must go all granular, like to the lowest level is what we want to use 1NF to achieve. So 1NF, it does not have to do with only the product name, because it has a comma and we have to now put it on a new row. No. Customer name too. That's why the word atomic value is there. It must contain atomic value. Each column must contain atomic value, so that we don't argue too much. So with this now, we've not actually achieved 1NF 100%. No, we've not. We still have something that we can still divide, something that we can still separate, and they can stand on their own, which is from the customer name. Is it clear to us now? Okay. Now let's go ahead to second NF. I'll give this one to us as like a class work, right? So I want us to open our Excel. Everybody open your Excel, a fresh Excel sheet. Is that in the way when you've opened it?
Opened.
Okay. On your first column, type student ID. The second column, type course ID. I can call anybody's name to share their screen. That's how I know that you are not doing it. The third column, type course name. First column, student ID. Second column, course ID. Third column, course name. And the fourth column, grade. Are we ready? Are we ready? Okay, on the first row, type student ID 101. Course ID, just type it as AZ900. AZ900. And on the course name, type Azure. And on the grade, type excellent. That's the first row. Student ID 101, course ID is 900, course name Azure, grade, just type excellent. Are we done with the first row?
Yes.
We have only 3 rows.
Please, sir, can you come again for the
Yes.
first row?
Student ID 101, course ID AZ900, course name Azure, grade excellent. Now I move to second row. Second row, student ID same 101, same person. Student ID 101, course ID DP600, course ID DP600, course ID DP600, course name Fabric, course name Fabric, grade, just put good, GWOD, good. The third row, student ID 102. The third row, student ID 102. Course ID is the 900. Course name Azure. And the grade, very good. Student ID 102. Course ID is the 900. Course name Azure. And grade, very good. How many rows do you have now together?
3.
Sorry?
3.
3, thank you. Now, I'll tell you what 2NF is about. Then you will now give me your results. Now, 2NF, you know that we have a primary key, right? Can you tell me the primary keys that you have in that table?
Student and course ID.
Student.
Thank you. Student and course ID are the primary keys we have on that table, right? Now, a combo of the two together is called what? A composite key. Right? Now,
Yes.
there is no course without students. Is that correct?
Yes.
So which one is depending on which one? Is it the student that is depending on the course or the course is depending on the students? Answer me. Oh. Which one is depending on which?
Cost is depending on the students.
Sorry? You said something. Say it now.
I
Can we
said
say that
cost ID is depending on the
It's
student
depending on the
ID.
student in this context. Okay, thank you. Thank you. Now, the rules of 2NF is this. There's something we call non-key attributes. And what is non-key attribute is your course name. Your course name is not a key, right? Your course name is not a key. Now, the rules of 2NF is that the non-key attributes, we will make sure that we remove what is called partial dependency. For example, now, course name, which is a non-key attribute, is depending on course ID and is not depending on student ID, right? That is partial dependency. It's not depending on student ID, but it's depending on course ID. It means that course name can on its own be linked to only course ID and it's going to be fine, right? So regardless of whether there is student ID, course name can be attached to course ID. But course name is not directly dependent on student ID, right? The only thing that is dependent on student ID directly is the course ID. But course name is an attribute of course ID. It's one of the attributes of the course table, right? So now, the rules of 2NF, 2 normal form, is that we remove that partial dependency, right? So each of the non-key attributes must depend on the O key alone. It means that this what do they call this course name? The way it should be is that any key that is not any of the columns that is non-key attributes must solely depend on the entire keys. But in this case now, course name is only dependent on course ID. And for us to remove that partial dependency, what do we need to do, guys? So I want you guys to now do 2NF now. There should not be any partial dependency. How can we break it down still? You guys can do it in 2 minutes, do whatever you feel is the answer, and we are going to make corrections. 2 minutes. Give me your new table. How will your new structure look like? How will your new structure look like in 2 minutes? There should not be any partial dependency. If there are any non-key attributes, the non-key attributes should directly depend on the O key. That is all the primary keys in that table. So if you are not partial dependency, what does that imply? What do you need to do to break it down? One of the first things is that for you to achieve 2NF, you must first achieve 1NF. 1NF must be achieved first before you can achieve 2NF. That's one of the first conditions of 2NF. You must first achieve 1NF before you move to 2NF. So can anybody share their screen? Let me see what your 2NF looks like. Should I call names? So let me call names. Victoria Nkolade.
I've not done it yet, though. I'm still thinking about it in my head.
Okay. Elsie. Elsie.
I'm still doing it, but I don't know.
Okay.
For me, I just thought maybe it's just to separate the course ID from the.
What about you, John? Can you share your
group.
screen, please? There's no need to explain yet. Just share your screen. Let me see what you've done. Salome should get ready. Please don't waste time. Share your screen as fast as possible. Let's move ahead. Elsie, what's the issue? I cannot see your screen.
I've not tested. I'm not done. I'm not done.
Okay. Tosin Omoleye. Who is done, please? Can you share your screen? Remove
Hello,
any
Mr.
partial
Benga.
dependency.
I'm not okay.
Continue now. You said okay. What do you?
I wanted to say that I'm
So in
not
a
with my
hurry to
laptop. I'm
leave.
actually doing it on my phone. So I don't think
Okay.
I'm able to
If you
share.
do
Yeah.
it on your phone, you can take a screenshot and share on the chat. Abdulaziz.
Okay, can I do a picture? Because I'm using my
Share your
phone.
screen, please.
I
Share your
just
screen.
okay. All right, hold
See
on.
what you're doing. Break it down to 2 NF. Should be simple now. It's not really you can see it like that too. You're not using your laptop to join the class. God of mercy. Salome.
Time, oh.
Alpha.
I still need some time, sir.
Okay, I'm seeing what Tosin is sending now. It's a little bit okay. Okay, I think it's bigger now. Okay, what do you intend to achieve with this, Tosin?
Mr. Benga, I'm still actually thinking. But I've just started doing something.
Okay,
That's
you've
what I've
only
done
gotten
so
half
far.
of the
Mr. Gwenga,
answer.
can you hear me?
Yeah, I can hear you.
What I did was that I created a fifth column called course code, and then I separated it from the AXI and the DP. So I put instead of
Why
DP.
do you need to add course code? I don't understand.
I'm just explaining what I did.
You don't need to add. You
You
already
can
have course
check.
ID now.
You can check what I did now. I just
Mr.
sent it on the
Bankole.
chat.
Mr. Bankole.
My guy, you want to share my screen?
You got the answer.
Wonderful.
You are going to get your gift today.
I get gifts.
Yes,
like
I'm also owing Elsie gifts.
Okay, I think
So
I'll
two of you now.
I'll start answering questions very well now. If there are plenty gifts available.
That's the essence of the. Let me see what Abdulaziz has done. Abdulaziz, you only created one table out of the table. Where's the second table?
Sir, I thought, okay, we have a table, student ID, course ID, and stuff. Then beside it, I created, I just had to do it on one place so you can see it.
You only created the course table. You created two tables out of that table. One table rather. And you're meant to create two. Look at Mr. Bankole's own. You see the way he did it.
Okay. Easy.
He has achieved 2 NF with what he just did now. No partial dependency. So having course name in that student table, in that main table, is partial dependency. Because course name is only depending on course ID. It was the one that got the answer.
All right.
Mr. Macaulay, share your screen and explain your thought process.
Oh, okay.
Okay, sir. Yeah. Can everybody see my screen?
Yeah.
Yes.
Okay.
Where's
Okay.
the main table?
Oh, add. Okay,
When you just create that table again.
I think this.
Okay, explain why you broke the table down like that.
Okay, let's hold on. Okay,
Who's
yes.
that now?
Yes. I beg. Okay, thank you very much, Mr. Benga. So first of all, for us to achieve 2NF, the major thing there is that our table must first be in 1NF, which we can see. Our table is already in 1NF from what we have here.
Okay.
That because all the values are atomic and there's no repeating group of data there. That's the first thing. So the second thing now is we notice that we have a composite there. The composite being the student ID and the course ID, because the two of them uniquely identify each of the row.
Okay.
So we have student 101 and EZ 109. It's actually different from student 101 and DP 600.
Okay.
So the primary key together, the two of them together make up the primary key, or as we have said earlier, the composite key. So now the next thing for us to now do is, okay, we want to go to 2NF. What's the major thing in 2NF? In 2NF, we must not have a partial dependency. So what does partial dependency? What are we not talking about? Is if you look at this, if you look at the grades of the students, the grade of students is actually depending on the student and the course the student took.
Thank you.
Right?
Yes.
So since the grade is depending on the course and the student, then in that case, it is not a what? It is not partially dependent. It's okay. But if you look at the course ID itself, Azure, Power BI, and Azure
course
is
name.
I'm sorry.
Course name.
Sorry. Course name. Good. So the course name is actually only dependent on the course ID.
Yes.
So Azure
is not depending on the two together.
It's not depending on these two together. So it can't stay here. So what's the best thing for us is for us to just do what? Apply 2NF. So to apply 2NF, it means we'll likely break down this table into smaller tables, into two tables. So where we have the one where we have only everything that is fully dependent, and this other side too that will be fully dependent. In addition, let's assume the student's name is now here, everybody. So if you have the student's name somewhere here, you know that the student's name is also only going to be what? Partially dependent on student ID and not on student ID and the course ID. So we are going to have three. That means we have another additional table that we have the student ID and the name of the student.
You too much, sir. God bless you.
You're welcome, sir. We are following your footsteps, sir.
Very nice explanation. You broke it down. Please, before we go ahead, is it clear to you now, guys? Is it clear to you now?
No, sir.
Who said no?
Okay. Can you, Bernard? Can you just Bernard or the leader speak? Can you just tell us where you think?
Yeah, I'm listening. It's from where you.
Hold on, please.
Okay.
How many of you is not still clear to you for 2NF?
Me,
can you do the raise hand button so that we can know how many people?
Okay.
It's easier for us to count that way. Okay, we have 9. We have 10.
Wow.
11. Maybe the new concept is still very, very new to people.
Yeah, that's it. Yeah.
We have 12.
Okay.
If somebody has dropped their hand. Okay, we have 12. Mr. Bakwale, please explain again for a beginner.
Okay.
Thank you.
Okay, for a beginner, my type of class, I want somebody to, out of the people that have raised their hand, either the lady or Bernard, one of them should open their mic and because I'm going to do it's going to be interactive. That way we'll break it down. So I want one of them to open their mic and just say hi or something. But Salome, go.
Yeah.
Hi.
Okay, Bernard.
Yeah.
Okay, Bernard. Yes,
Yeah.
Mr. Bernard. Good evening. So we
Good
have
evening,
this
sir.
guy here, right? We have this table where we have the student ID, the course ID, the course name, and the grades. You got all that part first.
Yeah.
Did you get that? Yes. Remember
sure.
when Mr. Benga explained 1NF. 1NF is to achieve 1NF, there must not be grouping. For example, let's say you are seeing Azure, Power BI in this place. You know, you could have had 101 or maybe 101, then Azure, Power BI, somehow, or AZ900, DP600. It might have been together, but we broke it down. So 101 is not appearing twice. So we have this one. So that 1NF has first gone away. So in that case, do you first understand that this is in 1NF? No grouping. Good. Now, if you now understand that part, the next part is, okay, if you understand the concept of primary keys, when you're explaining primary keys to people, should primary keys can they show more than one time in a table? Especially if they are in the beginning of the table, like this. Should they show more than once?
No.
They are not supposed to show more than once, isn't it? So
yes.
Now, you know, in another instance, we could have had a student table somewhere that would have had 101, 102, 103, and the names of that student in one table called the customer table.
Yeah.
Are you still following me? We could have had the course IDs as well. AZ900 is the name of a course called Azure introduction of something in Azure, an exam in Azure, right?
Yeah.
So that is another table entirely, isn't it?
Sure.
So, but in this case, our table now has two primary keys: the student ID and the course ID. At first, when I first asked you, should we have the student ID showing more than one time? You said no. But in this case, it's showing more than one time, but it's still a primary key. Why? Because in this case, we have what we call a composite key. We have what we call what, Bernard? Bernard? The other lady.
Key.
Thank you, Mopelade. A composite key. What does a composite key mean? A composite key is when two primary keys, or sometimes it can be two, sometimes it can be three, they come together to now become one single primary key. So when we have 101 and we have AZ900, the two of them become one entity. Abdullahi Bankole, that is in mechatronics, or that wrote AZ900 exam. Abdullahi Bankole is 101 and he has written AZ900. It's only the Abdullahi Bankole that wrote the AZ900 I am looking for, not the Abdullahi Bankole that might have written fabric exam. Are you following me, Mopelade and Bernard?
Sure.
Yes.
Good. Yeah. Now, since we already know that these two together make up a composite key, now the next thing is, when we have primary keys, usually we are going to have what we call dependents, right? Those that are depending on the primary keys. For example, when we had 101 here, you know that in this place, we do not have the name of the people, but we just have 101 sitting alone. But where we have AZ900, Azure is resting on AZ900, or AZ900 actually means Azure as well. Do we get that one?
Sure.
Same thing with DP600, meaning Power BI, or let me call this one back Fabric. I think it's supposed to be Fabric. And AZ900 back to Azure. Now, the next thing is, now that we have agreed on this part, let's now look at this other part. The last part, grades. This grade, what is it depending on? Excellence is depending on the person that wrote the exam. Good is depending on the person. I be on the exam itself. Yes, the exam that was
the
written.
two.
The two together. You know, Fabric alone is the exam. Azure alone is the exam. But grade, Excellent cannot just stay on the exam. You have to have taken the exam to have a grade. So a person took Azure 900 and it was excellent. Mopelade, Bernard, are we still on point?
Yes.
Sure.
Now that means that these grades are totally dependent on these guys. We agree that one. Now the next thing is, what will we now do to this boy or this column now? Because now, number one, if we add 10 of this now, this Azure 900 and is a 900, we keep on repeating itself. So, and since we already established that this is giving us a partial, what was it called? A partial dependency. What do you do when you have partial dependency? What you do is you extract that one that have partial dependency, you take them out. And what it means is that you could have taken this one, Control C, and let's say you paste them here, for example. Right? So when you paste them here, for example, now, you can see that it is not standing alone. But one thing is there's an error there. Can you tell me the error, Mopelade or Bernard?
The
Can you tell me
repetition. That's
their
the
reputation? Good.
Yes.
So since their reputation, I can just remove the one that is repeated. Pim. Then I have only this one. Now, what now happens? Since I've already extracted my course name from this other guy, if I remove course ID now, Azure can have other distinct, and Azure is not a primary key. So I can't really remove this course ID as primary keys, but I can remove these ones. If I remove these ones now, what will happen? This thing actually still what? Actually still makes sense this way. Right? But what has happened is that when we are doing 2NF, unlike 1NF, you could have multiple tables springing up from one single table. You know, we had one table earlier. We could have had more than one. Now, when we did 1NF, we were still sitting down on one table. It's just still that one table that we did. But in this case now, we are now having two tables. This same table, if there's other addition column, we could have had 3, 4 tables. Is that understood, Bernard?
Sure.
So that is where we are now.
Yeah.
So we now have this one, the student ID, the course ID, and the grades. They are all sitting down there easily now. So I know that 101, when it took is a 900, it was excellent. Now, based on what we want to do, modeling, we can now relate this course table. So we could have called this one course, right? Could have called this one course, and let's say we'll call this one, let's say maybe examinations or something. Who knows? Right? This can be another table. This is actually another table. So sorry. Now, so the very first table earlier now gave us these two tables where we can now relate course ID and course ID together in the modeling part. So what we are trying to do now is we are trying to now break into smaller parts, 2NF, to make sure that we don't have we don't have partial dependencies. Please, is it understood now? Maybe Mr. Gbenga should come again.
You've done the explanation sincerely very well to me. I don't know. Is there anybody that is not clear to, so that we can re-explain to you again?
No, it's clear now. Thank you very much.
You're welcome, sir.
Mopo, is it clear to you now?
Thank you, Bankole. It is clear, yes, sir.
Is it the first time you are hearing normalization, Mopo?
No, this is not the first time, but I always just watch videos, but I don't really understand it like on a real life scenario kind of situation. I just understand it theoretically, but I don't know how to explain it the way you did.
Okay. Please, I beg us in the name of God. Don't stop sharing yet, boss. Is there anybody still that is not clear to? Don't be shy. All of us are here to grow.
Hi, Abdullah. I just have a simple question. I'm clear already. I just have a simple.
Okay, sorry, hold on, please. When you say why does this matter? It will not. You say it will not matter in heaven.
You will know when it matters when you are working. When you are working with it. Okay, don't worry. When you start seeing some type of data, you will see why it matters. When we get to
Exactly.
modeling, when you get to
Exactly.
modeling, you will see why it matters. Mr.
It
Ahmed,
matters.
Abdullah Ahmed, my boss, you are here.
Yeah. So, when you are splitting the tables into extract tables, is there a time that we have to be worried about when the tables are getting too much?
Well, for me, I don't know if Benga would add to it. Sometimes.
Sorry, what's the question? Sorry, I didn't.
He said, should we be worried about tables getting too much when we start having multiple tables? Should we be worried about it getting too much? That was his question.
Answer him first, then I will just add to what he
said. Okay, sir. So for me, I don't see any issue to it because it just makes it much more easier. We have those simple dimension tables. What will just be happening is that we're going to be having a lot of dimension tables. And for those of us that are using whether it is schema, star schema or the rest, it makes life easier. I don't know if you get to Mr. Ahmed.
Okay. That's just
because Ahmed, if you had the student's name here in that first table that we created, that means we're going to have 3 other tables. And is it not easier when we have the student's full information in another table entirely, and then we add the course information in another table entirely?
I totally understand. Sometimes you come across a data set is like up to 100 columns. So when you are minimalizing that,
you start breaking down. You will break down. Definitely, it will definitely occur.
If you guys remember, that stuff we did in the first day of the class is still normalization. The first day that talked about conceptual model and logical.
Exactly.
It's normalized because we had a denormalized table and we broke it down. So let me tell you some of the reasons why, as a Power BI developer, you need to know about normalization, because you want to improve the quality of data. You want to avoid having so many duplicates and inconsistent data, right? You want to optimize your data model. You want to make sure that your data model is well optimized, right? And if there are no redundancy, if you avoid redundancy to the highest level, then you can achieve that optimization. Now you can make with your knowledge of normalization, it makes you create more clearer relationship between tables. You understand how different entities are related to each other, right? Now it's the best way of preparing your your tables for a star schema. Do we understand now? It's the best way of preparing your table for a star schema, right? And another thing is that it even helps you to reduce errors when you're writing DAX, because you don't have tables and columns all mixed up together. So do we understand now? Do you understand why this is very important for you to know? You please answer me or mute yourself. If she does not answer, we'll continue the class.
Yes, I do. My phone was hanging. Yes, I do, sir.
Okay. So is it looking like it's a strange thing to you? Yeah. Okay. Let's go ahead. Now let's go to 3NF before we go. So, Mr. Bankole, open another worksheet. Share your screen.
You want me to do 3NF too?
Yeah.
Okay, let me share my screen.
So, open another worksheet. Okay, so in this one now, I'll give you another table, just 4 columns. And we are going to turn it to 3NF.
Okay.
So the first column, student ID, second column, student name. Everybody, please do it. Please do it. It's not only him. I want to see your screenshots in the chat section. Student ID, student name, department ID, and department name. Now, we talked about partial dependency in 2NF, right? In 3NF, right, we are going to avoid transitive dependency. What does that even mean? So when we say transitive dependency, what it means is that tables must be able, some entities from the main table must be able to stand on their own. And it's very similar to 2NF. So for you to achieve 3NF, you must have achieved 1NF and 2NF, right? For you to achieve 3NF. Now, I said here that in 2NF, we are avoiding partial dependency. Here, we are avoiding transitive dependency, right? It means that from a single table, you must be able to bring out standalone tables that can stand alone without, even if they are not related. That is transitive dependency. I want you guys to do your research. This is our class for before we go. And break down these tables. So let me give you the table details. Student ID, I have 101. Student name, I have just put Onye because you know the year word. Onye. Department ID, put DO1. Department name. We are in this. She did IT. It's in IT. Second person. Put another person will stubborn for here. Okay. Put gifts. Gift to stubborn. 102. Gift is in.
Gift? Is it my own gift? Another one.
It's your own gift now. Are you not stubborn? Oh yeah, DO2. DO2. Gift. She's in training department. Okay, good. Now, how can we achieve 3NF here? Avoiding transitive dependency. Standalone tables that even if they are not related, they can stand on their own.
Are you saying I should do it or we should wait a bit?
No, I'm trying to get people to be active on
Okay.
this. So let me explain this transitive dependency again so that we understand what we are about to do. So it happens when a non-key column depends on another non-key column instead of directly depending on the primary key. So when a non-key column, so now can somebody tell me? Let me call name. Juliet. If I call you,
Yes,
please answer
sir.
me on time. So Juliet,
Yes,
tell me the non-key columns that are here in these 4 columns. So Macaulay, please zoom in a little so that this thing can become bigger. Yeah, thank you. Yeah. What are the non-key columns in this within these 4 columns that we have here? Let's start from there.
The department ID.
Non-key columns. Non-key. Okay, can somebody else try? LC. Non-key columns. Yes, LC.
I think
Sorry,
it
my
should
net.
be department name.
And
Change the
probably
department.
student name.
Family name and what?
Probably student name.
Probably. So you're not even sure.
Because there's many people can bear Onyinye here as regards
No,
this
that's not
that
the,
we are
that's not the
working with.
context. Don't mix it up. Just give me non-key columns here.
Okay, let's just stick with, from my hand, I'll stick with department name.
That's the only non-key column that is there, Victoria.
So we have the student name and department name.
Exactly. Those are the non-key columns now. You can't say department name alone. Okay.
So I said student name.
Student name. You said it, but you're now saying department name again, that as if it's the only one. Let's go ahead. So what happens when we have transitive dependency is that a non-key column depends on another non-key column, right? Instead of depending directly on the primary key. So how can you interpret that? Chidima. Now everybody won't be Power BI developer. Ordinary normal form, now they turn everybody like this. No allow. People that put Power BI developer now on their LinkedIn. Power BI developer is not being so. I'm telling you, it's the truth of the matter. You must be very knowledgeable. Because you are working closely with data engineers. You must understand what they are doing. Yeah. How do we interpret now? They said we should avoid transitive dependency.
Based on what?
Okay, continue.
Based on what you said about
Sorry
non-key
to
column.
interrupt. Please, let's fill the attendance form. Thank you. Can continue.
Okay, continue, Bumi.
Okay, based on what you said on non-key depending on another non-key, I can say here that department name is depending on student name, or either the student name is depending on the department name.
So what should we now do to achieve 3NF now? What should we now do?
I don't
when
know.
your hand is up, what should we do?
So my hand was up to answer the first question. Explaining
when I was calling your name, your hand was not up.
Sir, my network was disturbing me.
Shavina, I know you now. Okay. So what should we do? Answer this one. What should we now do to achieve 3NF?
So we need to separate them, because non-key column should only depend on a key column, not
on a primary key, right?
Yes. So I think.
So what are we separating from each other?
We'll have a student table that will have only the student ID and the name, and then we'll have a department table that will have only the department ID and the name.
Yes.
Thank you. Simple. Simple. Please just do that. Extract our student table separately from department table. Roberton. Achieve 3NF. So understand the keywords: transitive dependency and partial dependency. So non-key columns should not depend on each other. Mr. McCoy, sorry, you saying something?
Yes, I wanted to ask from my own end. The non-key columns the way I would have done this if it were me is, because what we did now, we have broken exactly what we want to achieve from this table. So I would have preferred that we had this department ID alone with this guy here. So we have these guys as one table. Then
because
this
of relationship, right?
Yeah. So this one, because the only key here is the primary key, which is the student ID. Every other one is depending on the student ID. Oyinye works in DO1, that is IT. And Gift actually works in DO2, that is in training. So this
Yeah,
is the
so we are still
primary
going to have
key.
the department ID on that table.
Yes. So the
Yeah, because of
department ID
relationship. Yeah.
has to be on that table, or else, because if you remove this now, what is the relationship now? How do I know where Onyinye is or where Gift is?
Yeah. You're correct.
Then we have already broken the model. So,
Yes, you're correct. You're correct.
Sorry, I have a counter.
Okay.
It depends on what you're naming the table. I said, we said student table. Student table just have student information. Department table just has department information. So
okay,
that new table that you've put now, maybe the name will now change to maybe, I don't know, courses, department of students or something. It's just student table. Okay.
Yeah. The question I want to ask you here is this: how often does it that a student department change?
Not often.
Exactly. So when you are filling your form or you are filling anything as a student anywhere in the school, you will surely want to put your department name there. That's that. So if this department ID is based for you to be a student, you must be in a department.
Exactly.
Do you understand that analogy?
It's correct, Onye.
I understand it.
It's correct. So which one is the, out of all these columns now, which one is giving us that transitive dependency for the 4 columns of them?
Okay, for the transitive dependency, the department's name is actually
the one that's giving us transitive,
it's depending on the department ID and not on the student ID.
Thank you.
This is the only one depending on this one.
So it's the one that's giving us that transitive dependency.
Yes, that's what that's giving us the transitive dependency. So we have to now break it down into 2.
Thank you very much, sir.
Sir.
Normalization 1, 2, 3. Is it clear? The class is ending now.
Yes.
Okay. So let me stop recording. And I have some things to tell you guys. Okay. I stopped.